this is part 1, and I'm gonna first basically give you a theoretical point of view of sets, and then I'm going to give you concrete examples and then teach you the notation. So first, let's start off with what set means. So we're gonna first start with sets by thinking that they're like a group. Like this is one group, this is one group, and this is one group. Now these groups, to make them special or to consider them to be something, we actually add numbers to them. So this could be something like 1, 2, 3, 4, and on to infinity. This could be -1, -2, -3. And then this could be something like 4 over 2, 1 over 2, 2 over 2. And basically what sets teaches us is that these blobs or groups are designed to group numbers, add the characteristics, just something about them. So let's start with using the notation. Now the notation is extremely simple for you guys, and let's just start off with it. So first we have our complex numbers. And they're very hard to comprehend, but just think that they're numbers that can't be written on by can't be written in a literal number format like I squared. So I is basically the square root of -1. But if we square the actual square root, what will we get? Will we get -1? Will we not get -1? It's very hard. And we just group it with saying I to the power of 2. Then we have our imaginary numbers. Now, I squared is also an imaginary number. We think of it like that. There are more complex numbers that are non-imaginary. This just happened to be one that was in both categories. So let's create a big blob here and give this proper notation and say it is C. Or for that, we'll give it complex numbers. Now we have the real numbers. Now the real numbers, unlike the imaginary and unlike the complex numbers, they can be written in a single format on the number line. You can see it. So we'll write them. Let me just so let's write it. So it's a complex number. Now we have real numbers. Now real numbers are numbers that are basically going to be encompassing all other sets that we need to remember. So just remember that for you guys. Okay, so let's start. So real numbers is like, let's give an example, 1.5. Let's give an example, -12.3. Let's give an example, it's pi. Let's give an example, it's the square root of 2. Now, all of these can be seen on the number graph. Like, if I had this here, number graph, I could see that this is 1.5, this might, and then when we go to negatives, -12.3, we have pi, and then we could have the square root of 2 just right over here, right up the alley. So all of these numbers are going to be in the complex group. Now, why they're going to be in the complex group? Because these could be written as multi-terms, a plus bi. So let's start off with that. So let's create this. And imaginary numbers can be written as I. So it's written like this I. Let's take that out because this is not properly written like this I. And then this is real numbers, which we write with this R. Okay, now we've got R. Let's go to the actual subset of R. The subset is basically the group within that group that's distinct from other groups that is within that group. That sounds confusing, but let me just give you a normal example. Imagine I have something called fruits, and in that fruit section, let me create a better circle. Okay, in that fruit group, there could be apples, there could be bananas. Who doesn't love bananas? And then there could be mango. And then there could be monkey. I meant there could be grapes. Okay, now for all of these are subgroups. These are all subgroups of grapes. These are all subgroups of fruits. So apple belongs to fruits, bananas does, mango does, and grapes does. Now, to understand this, we could see that apples are different from bananas, they're different from mangoes, and they're different from grapes. And that every single other fruit is different from every single other variation in the fruit topic. So let's just erase this. Let's talk about rational numbers. Now, rational numbers, they're the things like 4 over 2. There are the things like 1 over 4. They could be rational, which means that they could be talked about in a fraction, in a representational fraction. So let me write that for you. Key terms. We have representational fractions. Now we're going to be talking about irrational because, well, what if the numbers can't be seen in a fraction, like 4 over 2, 1 over 4? Well, yeah, I could imagine a number. Obviously, they're in a fraction. Now, to actually think about any rational numbers, we're going to have to think about a very complex thing. So imagine a number such as pi. Now, pi is equal to approximately 3.14159, blah, blah. And this can't have any fraction. I can't have any fraction besides this, and then you create an onset on that, which is a very dumb way to say it, but I can't have any fraction that represents this. The closest that there is 22 over 7, which I know that's crazy. So these two rational and numbers and then the irrational numbers, the rational numbers are going to be represented by q, and then the irrational numbers are going to be represented by q hat. This is a hat, and you might get confused because that looks like I'm dividing it. So q hat is just basically different. It's just different. It's it's just different from the rational numbers. The rational numbers that can be expressed in fractions with a representational fraction, and irrational numbers cannot. Now these are both inside the, let's go on here. These are basically going, I'm not going to write the irrational, but I'm going to write the rational for you guys. I mean, if you want it, but okay. Irrational is going to be Q hat. And now we are going to have Q. Now the reason why I have a big circle is because there's going to be more things, way more things that are going to come here. Now we're going to have integers, and then we're going to have natural numbers. Now, these are going to be represented with Z and N. So let's start. And integers is basically any whole number, negative infinity, negative 1. No zero, please don't add a zero. There's 1, 2, 3, 4, and you can even include plus infinity. Now, natural numbers are just 1, 2, 3, 4. Everything all the way up to infinity. So if we would see a number line here, and just say that this is 0. 0 is not included in natural numbers. We could see that all of these are something called natural numbers, or n, and all of these could be the integers, or z. So to say this, all of z is into n. So n is 1, 2, 3, 4. That is still a subgroup in integers, because all of the numbers in integers are also in the set of natural numbers. So we're going to create a z blob, and then we're going to create an I blob. Now we're done talking about sets. Now let me just answer a question that you might have. Now I've been talking in depth about these topics, but I haven't been talking that much about complex numbers. I just said that complex numbers, which is C, BTW, is also like I. C might be I, but that's actually extremely wrong, and we never want to think that way, so we're not going to. C is anything that is multi-term, A plus B, I, where you don't know, do not know. So I could be anything like negative 1 I squared. Now I is basically the square root of negative 1, but then I squared is something that we don't know. It's complex, so we just represent it with that. So let's take that away. Now that you've learned it, come to the next video. We'll go into the next topic, which is going to be quadrants, and we're going to learn about relations and functions, what their difference is.